All right, so we're looking at rational functions here. So the definition of a rational function is a rational function results from the division of one polynomial by another polynomial. To determine the equation of a horizontal asymptote, we consider the behavior of the graph of the function as x, the absolute value of x approaches infinity. So this is talking about as x approaches positive infinity or negative infinity. Okay, so I've just that's a really short definition. So we're going to look at our example question here. So we've got consider the function f of x equals 2x minus 6 over x plus 1. All right, and the first bit we've got to do is we're finding the asymptotes of f of x. Now, straight off the bat, we've got a denominator. So we know we're going to have a horizontal asymptote at x equals -1. Okay, and I'm just going to put that in here, horizontal asymptote. Okay, now the other thing we're going to have to look at here, so being a linear over a linear, we have seen these before, but let's keep going. So the next thing we've got to do is we've got to sort of work out, well, as x approaches infinity, we would see this denominator here would approach infinity, but this one here is going to approach 2 times infinity. And so we're sort of going to see this asymptote here at 2, but we want an algebraic way to figure this out. So what we do is we go, well, 2x minus 6 over x plus 1. I think, well, can I get an x plus 1? Because then I can sort of break this thing up. So if I go, well, 2x plus 1, okay, now this x plus 1 here, I've now added in, this is 2 times 1, I've just added 2 into my equation. So to balance that, I'm going to have to put a -2 there and then a -6 to balance them. X plus 1. Now, if you look at this, I've now got 2x plus 1 minus 8 over x plus 1. Now, the benefit of this form means I can break it into parts. So I've got 2x plus 1 over x plus 1. And then I've got minus 8 over x plus 1. Now, on this left-hand fraction, I've got those x plus 1s cancel out, and I'm left with 2 minus 8 over x plus 1. Now, it's a bit of work there, but the benefit of this means that now, as x approaches infinity, this thing here approaches 0, and this gives us our horizontal, oh, I got that the wrong way around before. This gives us our horizontal asymptote. So y minus 2 comes from this value here, is our horizontal. Now, I'm going to fix this. So horizontal, let's actually just copy that whole thing, and we're going to paste that down here. So that's our horizontal asymptote. And then I'm going to change this word to vertical. Vertical. Okay, so that's our first bit. Done, sweet. So I'm coming to sketch the graph of this function just because we've already worked out 2 bits. So let's just quickly put a graph in here. All right, x and y, and we just worked out our 2 asymptotes, and we worked out y equals 2. So here at y equals 2, I'm going to do a dotted line to represent an asymptote. So y equals 2. And then we've worked out our other one here was at x equals -1. So I've got this value here, x equals -1. And I always write my equations there. It's cool. So now we've got to discuss the behavior near these asymptotes. So what I'm going to do here is I'm just going to bring this equation back over here. And we're going to consider these in 2 different ways. So I'm just going to put a little line here. So let's consider the vertical part first. So vertical, I've got, if I look at as x approaches -1 from the negative side, so we're coming from this way here, from x, we're approaching this asymptote here, but we're approaching from this side here. I can think about just if I put a number in here, and I'm just going to put in, into my, let's just do it in my calculator. So you do the same thing while we're doing this. So in my calculator, I'm going to type in this fraction here, and I'm going to go, well, 2 bracket, and we're going to go negative 1.1. So I've gone 0.1 bigger, minus 6, and then over. So I've typed this expression, but I've subbed in, I'm just doing it as we speak. So negative 1.1, negative 1.1, and then plus 1. And I get this value here, this y value I got in my calculator is 82. Now, the important part of that is I got a big positive number. So 82 is a big positive number when I put in, so I'm going to put this up here in red because I don't usually do this. So for this, I subbed in negative 1.1 and I got 82. And this was my indicator here that this is approaching infinity. So let's just pick this green we're going to graph with. And so up here, I know when I approach from the negative side, I'm approaching infinity. Now let's go to the next one. So we'll go, if we approach that x negative 1 from the positive side, so that means we're coming from this side here, we're going to see what we get. And so same deal as before, but this time I'm going to put in negative 0.9 because that's just over here on the positive side. And so I put that in my calculator instead. So type that in. I'm in the run matrix mode. And I get negative 78. So this becomes negative 78. So this is a really good hint that I'm going, well, y approaches negative 78. So I now, in my graph, know that when I'm approaching from the positive side, I'm down here, and that's how I approach this asymptote. Cool. Now, the next bit here, we've got to consider our next bit as what happens when x, or hang on, let me change color so we stay. So now we're thinking as x approaches positive infinity, what is our value going to become? So positive infinity is, is down here. And this notation here actually is really handy. So positive infinity means we're going to have 2 minus, this goes to, actually I'll copy this over because this will be handy for us here. So copy, I'm just going to put that here. Okay, so this is going to be 2 minus 8 over, I'm just going to put infinity down here. Now, this is 2 minus, it's going to be like, this is pretty much 0, but it's going to be a tiny value. So what we're thinking about here is, well, if that's the case, then our y value is going to approach 2, but from the negative side. It's going to come from underneath because it's 2 minus a little bit. So this minus thing here means that when I'm graphing, I'm going to have to be underneath here. So it's going to be like this. And then the next bit here we go, well, x approaches negative infinity. We're going to have y approach. Now, if you're thinking of this value here again, let me just change. I'll change the blue. We've got 2 minus 8 over, and we're going to go to negative infinity. Now, this is 2 plus, a minuscule value because we've got this negative and this negative. The two negatives make a positive. So that means we're going to be approaching 2 from the positive side. So that means down here, we're going to be above 2. And so I've now got my asymptotes in there. So this bit's done, and we've considered that behavior. Find the axes intercepts for f of x. So this is easy. So x equals 0 means we put our function in here. So we're going to have 2, 0 minus 6 over 0 plus 1 equals negative 6. So we've got this asymptote, we've got this intercept here, 1, 2, 3, 4. Now, I'm going to have to sort of mess up my graph here. Originally, I did this to scale, but 6 will be down here, so it'll be really hard to graph. So let's be a little bit dodgy, and we'll pretend this is -6 here. Okay. Now, you should always draw with a straight line, so that's actually... Oh, maybe I should fix that, because that's really poor by me. So we've got our asymptote there, -6. And then our other asymptote is when y equals 0. So we've got 2... what am I looking at? 2x minus 6 over x plus 1 equals 0. So we've got 2x take 6 equals 0. 2x equals 6, x equals 3. Cool, I've rushed that so you don't see my therefore symbols, but let's just do the 3 there. And so this now goes something like so. And then over here, we don't have any points that we sort of care about, so we're just going to sketch that shape in. Now I've finished. I would graph this with my graphics calculator and use the trace mode, check these coordinates I want, and then I can also put, if I trace and I put x equals -1, I should get a math error for that one. And then I can also calculate y values as well in there, and I should calculate when the function equals 2, the y equals 2, or I could graph y equals 2 and press the intersect button, and it should show me that these don't intersect, and that's a good way to check my function there. All right, I'm going to stop that there.